Hello everyone, welcome back to my channel. I'm Preeti, a second year computer science and engineering student at Venkateshwara College of Engineering, Bengaluru. In today's video, we'll be discussing about first in first out page replacement algorithm. The table of contents of this video are introduction to page replacement algorithms, paging and virtual memory, why are page replacement algorithms needed and their types, and next we'll move on to our main topic that is first in first out algorithm where we'll be discussing about example, Ballard's anomaly, advantages, disadvantages, algorithm, code explanation and conclusion. Page replacement algorithms in operating systems. In an operating system that uses paging for memory management, a page replacement algorithm is needed to decide which page needs to be replaced when a new page comes in. Page replacement becomes necessary when a page fault occurs and no free page frames are in memory. Before diving into the actual topics, let's understand paging and virtual memory. Paging. Memory is divided into fixed size pages and processes are split into same size chunks that are pages. Pages are mapped to physical memory frames using page tables. Virtual memory. Virtual memory extends physical RAM by using disk storage to store inactive parts of processes. Allows system to handle applications requiring more memory than physically available. Now let's see why are page replacement algorithms needed. To understand why we need page replacement algorithms, we first need to know about page faults. Let's see what is a page fault. Page fault. A page fault occurs when a program running in CPU tries to access a page that is in the address space of that program, but the requested page is currently not loaded into the main physical memory, the RAM of the system. Since the actual RAM is much less than the virtual memory, the page fault occurs. So, whenever a page fault occurs, the operating system has to replace an existing page in RAM with a newly requested page. In this scenario, page replacement algorithm help the operating system in deciding which page to replace. The primary objective of all the page replacement algorithms is to minimize the number of page faults. There are three types of page replacement algorithms. They are first in first out, that is Fifo page replacement algorithm, least recently used, that is LRU page replacement algorithm, optimal page replacement algorithm. First in first out algorithm. This is the simplest page replacement algorithm. In this algorithm, the operating system keeps track of all pages in the memory in a queue. The oldest page is in the front of the queue. When a page needs to be replaced, page in the front of the queue is selected for removal. Now let's understand the FIFO concept with an example. Consider page reference string 1303563 with 3 page frames. Find the number of page faults using FIFO page replacement algorithm. Initially, all slots are empty. So when 130 came, they are allocated to the empty slots. So we can say that 3 page faults. When 3 comes, it is already in memory. So 0 page faults. Then 5 comes, it is not available in memory. So it replaces the oldest page slot that is 1 page fault. 6 comes, it is also not available in memory. So it replaces the oldest page slot that is 3, 1 page fault. Finally, when 3 come, it is not available, so it replaces 0, 1 page fault. So we have 6 page fault in total. Now let's discuss about Billard's anomaly and advantages and disadvantages of first in first out algorithm. Billard's anomaly. Generally, if we increase the number of frames in the memory, the number of page faults should decrease due to obvious reasons. Billard's anomaly refers to the phenomena where increasing the number of frames in memory increases the page fault as well. Advantages of first in first out algorithm. Simple to understand and implement. Does not cause more overhead. Disadvantages. Poor performance. Does not use the frequency of the last used time and just simply replaces the oldest page. Suffers from Billard's anomaly. First in first out algorithm. Let capacity be the number of pages that memory can hold. Let set be the current set of pages in memory. The first step is start traversing the pages. If set holds less pages than capacity, insert page into the set one by one until the size of set reaches capacity or all page requests are processed. Simultaneously, maintain the pages in the queue to perform Fifo. Increment page fault. Else, if current page is present in set, do nothing. Else, remove the first page from the queue as it was the first to be entered in the memory. Replace the first page in the queue with the current page in the string. Store current page in the queue, increment page faults, and finally return page faults. Now let's see step-by-step code explanation. The first one is header files. We are using hashtag include stdio.h and hashtag include stdbool.h. Hashtag include stdio.h is used for standard input and output functions like printf and scanf. Hashtag include stdbool.h allows us to use bool, true, and false. And the second one is utility function, and the function name is isPageInFrame. This function checks if a given page is already present in the memory frame. It loops through the frame array and returns true if the page is found, otherwise, it returns false. And the third one is main function, where we'll be writing our main logic, and the function name is pageFalse. The first one is input parameters, which contains array of page request, number of page request, the size of the memory frame. And the steps are initialization. Frame array represents the memory frame. It initialized with -1 to indicate empty slots. Front keeps track of the position to replace a page in Fifo order. Page faults counts the total number of page faults. Processing each page. If the page is not in the frame, checked using isPageInFrame, it's a page fault. The page is inserted at the front position in the frame, replacing the oldest page. The front variable is updated circularly using front plus 1 modulus capacity. And the fourth part is driver code. Input array of page request, that is the page reference string 1303563, frame capacity 3, output total page false. The result is printed to the console. Now let's run the code, but before that, let's quickly summarize what it does and why it is important. This program demonstrates the Fifo page replacement algorithm, where pages are loaded into memory following the first in first out rule. Every time a new page is requested and the frame is full, the oldest page in the memory is replaced. In the code, we check if the page is already in memory using the isPageInFrame function. If it's not, a page fault occurs and the oldest page is replaced. The program keeps track of these replacements using a front pointer. At the end, the program outputs the total number of page faults. This approach is straightforward and efficient for certain scenarios, but it does not always give the best performance. For instance, Fifo does not account for how frequently or recently a page is used, which can lead to more page faults compared to smarter algorithms like LRU. As a takeaway, Fifo is a good starting point for understanding page replacement, and it shows how operating systems manage memory under constraints. You can extend this program or experiment with different algorithms to see how they improve performance in real-world applications. Now I will show the demonstration of the code. In this code, I have taken the page reference string as 1303563, which we have discussed in the example, and the frame capacity as 3. As we run the code, we get the output as page false is equal to 6, which is similar to the result which we have got in the example. So we can say that this code is working good. Now let's have a conclusion for today's session. Key takeaways. Paging and virtual memory are vital for efficient memory management. Page replacement algorithms like Fifo manage limited memory by replacing pages when needed. Fifo highlights simple and easy to implement. suffer from Bilard's anomaly and does not consider page usage patterns. Real world insight. While foundational, advanced algorithms like LRU are more efficient in practice. Final note: mastering Fifo is a stepping stone to understanding modern memory management techniques. Thank you for watching. Please do like and share the video.